Hello everyone, I wanted to make a quick video about Michaelis Menten Kinetics, or the Michaelis Menten plot in specific. Again, if you like this, before I begin this video, if you like this video, please follow me here and on YouTube. I'm only going to put part of it here on TikTok. The full video is going to be found on YouTube. And now let's get back to the video. So as you can see, on the x-axis is the substrate concentration, on the y-axis is the reaction rate, and if you see, there's this part in the reaction that it's almost like perfectly going straight, and so it reaches a limit. And so this is about the enzyme, right? So the Vmax is the maximum rate that an enzyme can go. And because there's this point that it just seems to go on a tangent and it goes on forever, they kind of use the measurement of Vmax over 2 to see how effective, how fast, when I mean effective, I mean how quick the enzyme goes at Vmax over 2, because it hasn't reached yet that hyperbolic point, and you can, that tangent point of going on and on and on. And so it gives you a better measure to be able to compare different enzymes. And another thing it gives you is that if you notice at this point of the Vmax over 2 that I have here in green, actually I have it up as a black dot, this specific point. If you go down, this is in relation to the substrate concentration. And this value, this point on the dot, is the Km. And what the Km tells you is, it doesn't tell you, like, in other words, if you have a high Km, it doesn't mean you're going to have a low or a high Vmax. There's not a relationship in the sense that this dictates how good or how fast or how anything. It doesn't dictate the Vmax. What the Km does tell you is it tells you the affinity of the enzyme. So, in other words, if you have a high Km, the enzyme has a low affinity. If you have a low Km, the enzyme has a high affinity. And again, it gives you the concentration at specifically Vmax over 2. And I think that those are the major important points. So remember that, again, the Km doesn't dictate how high or how low the Vmax is if there's not a direct relationship. Now, the Km has an inverse relationship, again, with the affinity. If you have a high Km, you have a low affinity. If you have a low Km, you have a high affinity. And again, it gives you the concentration of Vmax over 2. And again, the Vmax depends on the amount of enzyme. So this is a really important point. If you have more enzymes, you're going to have a higher Vmax. So a way to give you this more like a better understanding is you have a factory. And so at first, when you have your factory, let's say you give 5 parts, okay, they got it. They give you 10 parts, they got it. 100 parts, they got it. But then there is a point that the factory, it doesn't matter how much substrate or how much you give them to work with, they're going to put a specific output, and that is the Vmax. But if you open more factories, if you have more enzymes, you're going to be able to produce more, and your Vmax is going to increase. So think of it as the parts as the substrate concentration, and the rate or the Vmax as the factory. And the Vmax is the max that the factory can put out. And I think that that's going to help you understand better, because this is in relation to an enzyme. But again, if you have more enzymes, your Vmax is going to increase. So again, I hope you liked this video. If you did, please follow. And thanks again for watching. Like and share. Thanks.